Okay, 4.8 part 2. Just a quick reminder up here to be turning in those homework assignments. So that first one from 4.8 about adding, subtracting, multiplying with imaginary. You could be checking those odds in the back and turning them in. If you're struggling, ask possibly the sub can help or maybe one of the other students from class. So just don't forget to be turning those into the basket as you're getting them done. All right, so yesterday we did add, subtract, multiply, divide with imaginary numbers. And today, we add, subtract, and multiply yesterday. Today we're going to actually do dividing. All right. So that's kind of the goal is just to divide complex numbers. And when we do this, we're going to use something called complex conjugate, or I'm probably just going to call them conjugates throughout these videos. And if you want to take a quick note of what a conjugate is, they're pairs of numbers that have like real and imaginary parts. And the real parts will match and the imaginary parts will match, and the only difference will be one will be a plus and one will be a minus. All right, so probably a good way to just kind of talk about this is here's some examples. So this first one, its conjugate would have the same real part of 4 and the same imaginary part of 3, and then the only difference is the symbol in between them is a minus. So that would be the conjugate would be 4 minus 3i. All right, here's one for you to try. 7 minus 2i, what is its conjugate? Okay, so the answer here should be just 7 plus 2i. So keep the real part, keep the imaginary part. The only real difference is to switch the symbol between them. All right, so conjugates are magical. They have this magical property which we're going to use when we do division with imaginary numbers. So that magical property comes out when we multiply them. So if we want to watch this example here, we just multiply like we did yesterday with FOIL. So we get 49, and then positive 14i, negative 14i, and negative 4i squared. Okay, and the magical part here is the imaginary things actually disappear. Plus 14 and minus 14 cancel each other out, and we're left with 49, and then we're going to be minus negative 4. Once I squared is turned into negative 1, we'll have 49 minus negative 4. And so this just becomes 53. And so kind of the magical part is we started with some imaginary numbers, but the imaginary parts cancel out, and we end up with just a regular number, a real number of 53. Right, so that's kind of the magical property for conjugates. All right, so how this starts to apply to division is you don't really divide the number. So I think it's misleading to say we're dividing. I think a better thing we're going to do is we're actually going to be simplifying problems with imaginary numbers. Okay, and so a quick rule to jot down is when we're in a division situation, the rule is basically whoever made up the rules of math said no imaginary number in the denominator. All right, just kind of a rule of math. So what we're going to do is try to simplify this expression to get it so that we no longer have the imaginary number in the bottom. So the trick is we kind of got to think we can multiply, like what can we multiply the top and bottom to make the I disappear? All right, and maybe we did this before in the past. Like if you have a fraction 3/4, you can multiply by 2 over 2, and it really doesn't change the value of the fraction. It just changes it into kind of a different form. All right, so we're going to do a similar idea here. We want to multiply the top and bottom by the same amount and get rid of the I. So the trick is, maybe some of you figure this out, is if we multiply by I for this particular question, then we'll get 3i squared in the denominator, which basically becomes negative 3. Right, so we've met this rule that there's no longer I in the denominator. Because we multiply by I in the denominator, we also have to multiply by I in the numerator. It'll get distributed, so it'll be 9i plus 12i squared, which just cleans up to 9i minus 12. Right, when we replace the I squared with negative 1, it's just 9i minus 12. And sometimes the 3 divides evenly here, so you could clean this up a little bit further. I'm not super worried if you don't get that final step there, but it actually cleaned up a little bit further to this. Okay, so I'm going to do one more with you here. Goal again is to no longer have I in the denominator. So here's where our conjugate stuff's going to come in. All right, because we need to make the I part disappear, and that's the magical property of conjugates, is when you multiply two conjugates together, the imaginary parts disappear. So for this particular example, the previous one was a little simpler because we just had 3I in the denominator, but this one's a little more complex, and so we need to multiply by the conjugate. Okay, so in this case, it would be 3 minus 4I, right? Just the conjugate of 3 plus 4I. All right, and so in the denominator, I'm going to do all these steps kind of below the denominator here. So I'm going to FOIL to get 9, and then minus 12I, and plus 12I, which are going to cancel out, and then negative 16I squared. So clean all that up. The imaginary parts cancel out. So we have 9, and then we're going to have negative 16, or minus 16, and then the I squared will be a negative 1. So we end up with 9 plus 16, or 25. All right, so our denominator has cleaned up nice and pretty to 25. Numerator's got a little bit of work to do. So we distribute the 5, and we get 15, and then minus 20i. And that's pretty much it. So we didn't really divide anything here. We just made it so that the denominator no longer had I in the question. Okay, and technically, again, if you want to clean this up, all of these are divisible by 5. So again, I'm not super worried if you don't get this last step. Really, either one of these answers is okay. All right, so I'm not going to go through and do all these problems, but these are examples here of we want to get rid of I in the denominator. Okay, so it's kind of different depending on the situation, but this first one, again, we would just multiply the top and bottom by conjugate. This would be 1 minus I to top and bottom. I'm going to have you try this one real quick. What would you multiply top and bottom by? Answer is conjugate. So you keep the negative 2 part and then just flip the sign with the imaginary part. So I'd be minus 2 plus 5i, and you do that to both the top and the bottom. Last example here is a little bit different because it's just a 3i, and if it's just a regular number with I here, you just multiply the top and bottom by I. Okay, so I got 2 sample problems for you. I'm not actually going to have you turn these in because I'm not here right now, but I'm just going to have you try them and then submit your answers in the computer here. Okay, so you can check your work against mine. First one, we're just going to multiply by I on top and bottom. So in the denominator, we'd get 6i squared. In the numerator, when you distribute, you have 4i and then minus I squared. I times I is I squared. So clean it up. I squared is negative 1. So the denominator is like 6 times negative 1. And so we end up with 4i plus 1 over negative 6. Second example, multiply by the conjugate, so it's 2 plus 4i. And in the denominator, FOIL things out. So we'll end up with 4 plus 8i minus 8i and minus 16i squared. So the middle parts cancel out there, the positive negative 8i. So we end up with 4 minus negative 16, and we end up with 20. So our denominator would just be 20. And the numerator, we just got to distribute the times 3, so it would be 6 plus 12i. Sorry, that kind of didn't fit there, but that's a 6 plus 12i. And again, that would actually clean up a little bit. So that's a fine answer, but if we wanted to clean it up down here, just divide everything by 2, it looks like. So 3 plus 6i over 10 would be a little bit cleaner of an answer. But really, either one of those is fine. All right, so kind of a second part of this lesson. So we're kind of switch gears a little bit. That was dividing with imaginary numbers, but there's kind of a second part is start to solve a quadratic equation with imaginary numbers. All right, that's kind of what we're building towards here. That's why we're learning all the imaginary is we're going to solve quadratics, which again is just an equation with x squared in it, using when they have imaginary numbers, right? When they're non-real answers, which we couldn't do previously. Here's a quadratic, all right, an x squared equation, and hopefully you're learning this chapter that when you have an x squared equation, we have a bunch of different methods. All right, there's algebra steps, factoring, graphing, quadratic formula, all right, and previously we talked about graphing kind of works for all real numbers. I really like graphing, but it only works for real numbers, all right? And so for these imaginary ones, the two methods that are going to work, factoring and graphing won't work. Algebra steps will work, and the quadratic formula always works. That's like the default. It works all the time. For this first part, this first section here we're actually just going to use the algebra steps method. All right, so they're all going to be problems like the one that's shown above here, where you don't have an x part in the equation, you just have an x squared. And so you're able to solve it with algebra steps because there's just x squared, not an x part. All right, so if you want to copy down this example, click here, and we're going to solve it, and we're going to get some imaginary numbers. All right, so algebra steps, we just minus 32 from both sides. We're going to get x alone, divide by 2, and now that we have x squared isolated, we can square root to cancel it out. And so here's where our imaginary stuff comes in. Previously, we couldn't do the square root of negative number, but now with our friend I, we can do that where we pull off the I part and we say the square root of 16 is plus or minus 4, and the square root of negative 1 is I. So our two answers are plus or minus 4I. All right, so we found some imaginary solutions to this quadratic equation. All right, second example for you. I'm actually going to have you try it quick. All right, so we're just, all the ones in this section when you solve, the solve ones will all be doing algebra steps. So just get x squared alone, then take the square root and do simplest radical form. So 15 is not a perfect square, and there's no perfect squares that evenly divide 15. So I'm just going to pull off the negative 1 part and then say, okay, well, we can't really clean up square root of 15, so we're just going to leave it. But we're going to put a plus minus in there because we know that there's both a positive and negative square root. And then the square root of negative 1, we're just going to replace with I. So our two answers here are plus or minus square root of 15I. Okay, last example. I'm going to have you copy this down in the notes with me. The only thing that's different here is this one involves fractions. So it's kind of goofy when you do your answer here. So I just wanted to give you one so that when you see this in homework, it doesn't freak you out too much. I'm not going to worry too much about the fraction part, but we're going to use algebra steps. Again, there's no x part. So we can do our algebra steps. So we're going to add 3 to both sides and then divide by negative 4. So we have x squared equals negative 3/4. Square root to both sides, which is going to give us imaginary numbers. And so how to clean this up, there's other ways to do this, but I'm just going to say, okay, pull off the negative part and just basically say our answer here is going to be plus or minus the square root of 3/4, even though that looks kind of goofy with an I on the end for the imaginary part. The square root of negative 1 becomes I. So there'll be at least one like that to watch for in homework. All right, so here's the homework. There'll be some where you're dividing with imaginary, and then there'll be some where you have to solve and get imaginary answers, kind of like the last one. So there's kind of two parts to this. Good luck.